So here we want to measure, we want to find a bunch of circular objects. You can see the lab video for more. Coffee cups, plates, clocks. You're going to see balls, right? As long as you take those, able to take the diameters, and you want to measure and record 6 different circumferences and 6 different diameter values. Okay. Now, sometimes it's hard to measure the circumference. So take a piece of string and measure all around that object, and then measure it out using a ruler, or in that case, it's probably our measuring tape. It's going to be hard to do a caliper because it's not that tiny. Okay. Now, what you're going to do with those measurements is you're going to record all that in your data table, which you have up above. Okay, so you got 2 parts. You state the object you use, put the circumference and diameter values. Now you're going to want to make what's called a best fit line there. Okay, so here it says when you're doing your data analysis, you'll have that data, and then you're going to make a best fit line that comes up down when we're doing the questions here. Okay, there we go. So I'll show you real quick how to do this on Excel. There's other graphing software online that you can use. Okay, so here I have a plot here in Excel, but let me go back and start from scratch. Okay, so I'm going to pretend and start from scratch. I'm going to do a whole brand new table. And you get Excel and all those resources for free. So there's links to that on the page. If you're having problems, just let me know. There's also, you want to make use of the Student Success Center. They have a lot of good resources on how to do a lot of this as well. So what I'm going to do is I'm going to go ahead and put my values in. I'll just put 4 values in. And I could put, let's say I have a diameter. I'm going to do diameter, and I'll do circumference. And I have a diameter of, I measured 6 in terms of centimeters. So you might want to put the units you use, because you might have to convert those to meters later on. Always be aware of your units, because it can really create big problems when you're doing labs. That's why we're emphasizing units at the very beginning, because further on down the road, I've seen students that just made a mess out of work just because of units. They really went down the wrong track because they forgot to convert 1 unit. So let's say we measured 6 centimeters as the distance across. So the diameter, of course, is going from one side through the center of the circle to the other side, and 2 radii equal 1 diameter. So we measured 6, and then let's say we measured a circumference of 19. And then we measured 4 centimeters for the diameter. And then we measured 15.2 for the circumference. And then we measured 1 for the diameter and 3.2 for the circumference. And 8, and then 20.3. You want to do 6. I'm just going to do 4 just to show you how this works. Okay. So I put my data in Excel or some sort of similar spreadsheet. I think you could, like some of these online tools also have ways of doing the table for you, which I'll show. And the next step is I want to highlight this, and I want to insert, and you could go here to charts, and I want to do an XY scatter plot here. There we go. Okay. And then what I want to do is I could go to insert add chart element. Okay, so I could go to this menu right here where it says add chart element, and I want to go to trend line. Now what I'm seeing, and you might already have a suspicion of where it's going, right? So that makes it a little easier. But what I want to do here when it lays out for you in lab, as far as the post lab and the questions go, is you want to make a linear fit out of that. Okay. and you can put a title in. So I'm going to take these scattered points and I'm going to say there's some sort of correlation. And we have something called the correlations coefficient statistics, which tells you how closely it stays in that line. But this allows us a basis to maybe predict future values. It looks like it's going in a straight line. And now what I want to do is also choose more format options. So let me go to trendline and go to more trendline options. And the nice thing here is I could also fine tune it. Maybe I'm seeing an exponential value or a polynomial. A quadratic would be a polynomial of order 2. If you're looking at especially like 2D motion, like projectile motion for position time curves. We'll get into more of that a little later, or power curve. But right now we want to really make sure we're down with how to do linear fits. Now, what I want to do is I want to also display the equation on the chart so I could find the slope. Okay. And let's see, what else do I have? I might want to change my title. And this title is circumference as a function of diameter, right? And the idea is if we increase the diameter of an object, we increase the circumference of an object by a factor of pi. It's proportional via the value pi. So circumference versus diameter. Okay, you could add intercepts in there too if you want to extrapolate. Okay, so here we have our chart, and let's see, I can blow this up a little bit. And that's just a basic linear fit here. Let me make that bigger. All right, but you could increase this. All right, so there's our slope. So here I have, this is the equation that I want to write down in my lab. There we go. That'll make it. Sorry, it's a little too much. There we go. Let's see here. There you go. You can see what the slope is and what the intercept I have. So that's the basics on doing a linear regression. I'm going to try to have a more formal one. There's more than one way to do it, but that gives me the basic relationship in the slope. And that slope is not looking very good. I should put in, if I go back to my trendline options and go back here, and I should set my intercept to 0, 0. Okay, that's going to be much better. And then display equation on chart. Erase that one. And my intercept should be 0, 0. And the idea is, okay, if I have like a 0 circle, right? 0 diameter equals 0 circumference. That one I could add in with complete confidence. So you notice how that changes your equation and you have no y-intercept. So now my slope is more like 2.9. So that's your slope. So here we have the y equals m. M is 2.9094x plus b, and b is 0. So be aware that in this case, it is advisable to add in your x-intercept, your y-intercept, sorry, but it just depends on the type of problem that you have. You can't always do that. Now, some other tools that I have here, if we just wait patiently, I'm going to try to pull this up, and then we'll just have to end it, and then I'll have to continue a little bit on Tuesday and answer questions on discussion board, and then email for emergency. Usually if I get an email, I try to share that with the discussion board.
I have a quick question.
Mm-hmm.
So suppose if we want to refer back to one of these Zoom meetings, is there a place where you can post the recordings?
Absolutely. I'll put it right on the lab that I talk about the lab parts with on that resource page. So this will go under the lab 1 page, but I'll also put it on the main lab page because I did some intro lab stuff. And in addition, I like to have like a page that's like some Zoom recorded sessions. And I'll always put a date with it too, so you know which Zoom it was.
Perfect. Thank you.
Okay, you're welcome. And of course, if you can't find it, you know what? go to that discussion board and say, I can't find the Zoom link for this lab information, and I'll post it for that lab Q&A. So sometimes we could get lost in so many things. I know I can't even find the page that I had here, so hang on. I just had a really good page of a bunch of oh, here we go. Okay. I'm going to show you this as well. So here's some other places you could do these. Like here's a linear regression calculator, which is a linear fit, but we use in statistics to see how well it correlates, right? So I could put the same values I had, like 6 for diameter, but just remember your X is your diameter. And this is your circumference. And I'll put links to this. I might put links to the linear regression calculator right on the main lab information page because this is useful. There's a lot of really good places to do analysis. 619, 4, 15.2, 1, 3.6, and we had 8 and 20.3. Okay, let's go ahead and calculate now and see what this does. This is GraphPad, and you can see it does a correlation here. The nice thing, what we're really interested in, is this information, but notice the slope is down again. It's like 2.423, and that's because we didn't set the 0, 0. But if I go back, well, let me go back. Oh, I erased it. I have to redo it. 6, 19. But I'm going to add 0 in here because it really, I did that with Excel. But this is going to make a difference in how I do my slope. 4, 15.2. And then we have 1, 3.6. And then we have 8. Whoops. 20.3. Okay, now let's see what a difference that is. See, notice how the slope goes up? So this could be helpful, and you could take a screenshot and insert it into your lab or copy and paste it. And there's many other applications. Like for my stats class, I use StatCrunch a lot. And that's when we really want to do a lot more like analysis. Like later on in physics, you'll be doing a lot more on like probability distributions and so on, because when you're, especially when you're doing particle physics and you're looking at like, atoms and locations of atoms and behaviors of atoms and energies of atoms, it's like a lot of statistics and probability. So you'll be using a lot more sophisticated packages. Now, one of the things that I hope that we could get as a college, and we're going to try to get for physics classes, whether in person or online, is Mathematica. That's what I would advise for students to invest in. If you're really serious about having a career in physics or in math, Mathematica is really awesome. There's some stuff in a little later on, we'll